Welcome back to Made Up of Wires. We're decompiling Hacker's Delight 2nd edition. If you don't have that book, get it from your library or borrow it from a friend. Fantastic book about bit twiddling and lots of fun things. And sometimes we come across those things in Symphony of the Night when we're decompiling it, which of course is what we're going to do today. You can go to soten.z.dev to learn more about the Castlevania Symphony of the Night decompilation project. I threatened it for a long time, but Top is finally in Castle Keep. We decompiled the whole thing in a couple weeks, maybe 2 weeks. Pretty fast from start to end, and now we can see the fruits of our labor. Not ST0, but Castle Keep right there, Top. And of course, RTOP. Oh, but RTOP hasn't showed up yet. RTOP will be in there. That has been checked in. And I do need to update the docs directory to get the graph there, but I'll do that eventually. It's not as important, I feel like, to get a graph for an overlay that's done. I do want to start adding data to these graphs. We do have data available to us as well, so we do a lot of code decompilation, but the data decompilation is as important as well. If we want to be able to retarget or make the code base portable, we need to be able to recompile the data as well. And so we have some tooling for that. Sometimes it doesn't work as expected, especially on the bosses, as we've seen, but we're working on that as well. The other thing that I was looking at recently, so I feel like every time I submit a PR to a new project, I'm intruding in a way that offends people. It's probably just my lack of tact or style. I don't know. I tend to get responsive. Why would you want to do that? Anyway, so I have some PRs pending for MWCC Gap, so that we can get our dependencies, as well as Weibo. I haven't heard anything from the Weibo project yet. Basically, that's adding some feature parity with Wine for path translation, and then some path lookup stuff as well. And then the next not decompilation project, but just project management project that I think I'm going to look into is our build performance. So getting dependency tracking working and being able to do minimal comprehensive builds is great and allows you to do all the things that you want to do. Everything that I do on the channel is open source, so yeah, it will be. Hey, Guest73, good to have you, Dizik, on YouTube. So the other thing that interests me greatly, especially as we get more overlays for PlayStation, there's going to be 60, I think, between 60 and 70 by the time we're done, is build performance and build time. So currently, I think when I started, we were around 14 seconds to do a build from clean to the end. And now we're up to about 30 seconds. We have way more code, and so as builds get longer, I go back and I try to tweak things to make builds shorter. But we went from compiling a few hundred files to now compiling, building, I should say, and support files around 2,000. So things take a while. And so where is our time being spent? What can we do? So the first thing you have to always consider is, oh, now I need to find where this where this graph is that I was looking at. You always need to consider where time is being spent. And I love optimization. It is, to me, that's a ton of fun. Maybe not to you, but I like optimization. I like looking at all the graphs, all the numbers, finding the hot spots, seeing what I can optimize. And this is the cost of our Ninja build, or the time it takes to do our Ninja build. Ninja nicely splits this up among as many processes as it can, or as many threads as it can, and tries to do as many of these things in parallel as it can. But we have a lot of stuff, and you can see this build from clean. It looks like it was taking about 35 seconds. And it becomes pretty apparent right away where our time is being taken. It's generating our linker scripts. And what is responsible for generating our linker scripts? It is Splat and Spim. And so what is taking all that time? Python is taking all that time. If not so much Splat doesn't do a ton. Spim does a lot more. Spim is the disassembler. If Spim was written not in Python, would it be much faster? Yes, it would be. And just rewriting it not in Python would give us a huge speed boost. But it's in Python, and it is a very comprehensive and reasonably large project. Yeah, I mean, ultimately, what can you do? Guest73 suggests rewrite it in Rust. Why not rewrite it in C? No, I'm not going to rewrite it, at least yet. It does rely on a library called Rabbitizer. Rabbitizer's used for decoding instructions, and it actually already does have a Rust implementation. It has several parallel implementations, one being a Rust wrapper around the C implementation. It also has a Python implementation, which I believe is pure Python. Yeah, Rust does do love saying rebuild it in Rust. So what can we do? Again, we profile. We have to profile. This is a flame chart. Flame charts can be good, can be bad. I don't really like this inverted flame chart. I really like instruments, and you can do an inverse call stack in instruments, and I find its implementation of an inverse call stack easier to read. I don't understand, like in my brain, I don't understand a timeline than with a tree underneath it, because a bunch of these nodes in the tree are going to be the same. Some of them are going to be different. And so if we just construct a tree to begin with, anyway, not important. A tree is super valuable, and an inverse call tree, super valuable when doing profiling. Timeline can be valuable as well. Flame charts can be. But let's kind of dig into what's going on and why this assembly is expensive and what can we do. The first part is a bunch of stuff that Splat is doing. The gaps here, I'm assuming, are I/O. I have to look into this. Python is not my language de franca. And profiling it makes me super frustrated because things that are fast in other languages are just not in Python. And things that you think would optimize code in Python just don't, or work the opposite of the way you would think sometimes. So I was looking through this, trying to figure out where time is being spent. And we have a lot of these. So these are symbols. A symbol gets pulled in, looking at the symbol table, looking at the size of that, and then some logic is done to try to determine what that is. And one of the things that happens a lot, as you can see, and it takes a lot of time, is trying to figure out or query a symbol for what its type is. And when you do something like ask a type, if it is a string, it actually asks itself, is it a Pascal string? And if it is, then it's not a string. And if it's asking itself, is it a Pascal string? It asks itself, is it a string? And so you have this interesting inverse relationship between those two functions. But we have a bunch of these, like all these type functions that together end up taking about 10% when you add them all up. Pretty significant. Get type special relies on those same is string and is Pascal string methods. So if we can optimize those, we get that for cheaper. Get symbol and get segment for VROM. I'm not going to talk about those. This implementation is suboptimal, and it's basically an O of N operation for every get segment from VROM when it really should be near constant time. It can't quite be constant time, but it can be very close. And so we're going to do that. I'm going to look into that later. Get symbol. We can optimize that as well. Get symbol looks at a sorted map, but most of the time we don't care. We just want to see if there is a symbol at our location or not, so we can get rid of a bunch of stuff there. And we go on and on and on and on. And can we optimize SPIM? Some of this, unfortunately, ends up being, I think the Pythonistas would say, not Pythonic. And sometimes I don't care. I don't care what the Pythonistas think. I think they're a little full of themselves, honestly. So we need to maybe do non-Pythonic things because it's wasting our time, and our time is our life. And so screw the Pythonic way if it's wasting my life, honestly. So I did look at a bunch of these things. Can we pre-compute types in a bunch of cases? Yes, we can. And we can get rid of the vast majority of time looking up types. Like I said, we haven't looked at get segment for VROM. What this does is effectively looks at all of the segment information. We've looked at that in Splat. We'll look at DRA because DRA is our most complicated one and actually a good test bed for how these get broken up. So every one of these lines is a separate segment minus the ones that are commented out. And when you're looking for a symbol in a particular segment, currently SPIM looks through every segment until it finds the one that the symbol could be in, order n. But what do we have? We have actually a very straightforward table of ranges, and there's several different ways to do that. There's computer graphics ways like KD trees to do that. There's virtual memory ways to do that through TLBs and other things like that. There's ideal hash trees. There's lots and lots of ways to do near constant time lookups of addresses in ranges, and we don't need to do that order n, so that'll be later. I haven't done that yet because that requires writing more Python, and I don't want to do that. And what else did we fix? Get symbol actually is much faster now, and we can look at one of these. This is probably one example where we're taking about 0.6 seconds in that function. I think that's how this is read. Whereas before, that's right after the long get segment for VROM. So 0.7 seconds. So maybe 10 to 20% benefit there, but that goes on and on for all these. Anyway, so I'm gonna spend some time working on that, and then this is another case where I'll lovingly submit a PR to the SPIM project and say it's faster now, and they'll say why. This is ugly. Because I like my time and I like my life. That's why. So let's get back to B06 and see what we have there. So yesterday, thanks to Dizek, thanks to many others, we got through a couple functions yesterday. and we know a little bit more. We're going to look at BO4 and BO6 together and kind of try to match those up. BO4 is Doppelganger 10, BO6 is Richter, boss fight. Guest73 says, for computational stuff, Python is 100 times slower than C with standard optimization. Yeah, I wouldn't be surprised if it's even more than that. So if this was all written in Ruby, which is a language that I do like, and I'm very productive in, and you came to me and said, we wrote it in Ruby because Ruby's easy to read and write, and it's easy for other people to maintain, but it's slow. I'd say, I know, but it's Ruby, and everybody loves Ruby. Nobody loves Ruby except me. But because it's Python, and I hate Python with the fire of 1,000 suns, I don't care. Harsh, but true. I really don't care. And it disappoints me to no end that Python became kind of the language that people write things in. Is it better than Perl? No. I say that with some disdain for Perl, but probably tens to hundreds of thousands of lines written in Perl. Perl is a write-only language, so I understand projects that don't want to have many people working on Perl. So we did this entry method yesterday. So this is the entry point for Richter, and it's going to do all the things that Richter needs done. And every time this gets called, or every time we update a frame in the game, this function is going to be called and ultimately call other functions that determine what Richter does. Oh, interesting. So, guess 73, you were doing. Sorry, I'll get to. I will craft in a second. So you're doing like translating Turing machines from one to the other. Part of it, I think, too, and like I don't. I used to, and I have professionally programmed in C++. Not a lot, not for a long time. But I do appreciate a lot of the Bjarne Stroustrup ideas of like making it pragmatic and looking at what the hardware does and optimizing for that case. And I feel like that's not what Python does at all. And so I totally see something like a Turing machine, like where all of your allocation basically fit into probably 1K of RAM that's all cached on die, and then Python's just like, no, I'm going to spray this all over, and you have a reference to everything, and I have to do a million memory lookups and your cache is blown. Have fun. I Will Craft says, the first time I hear a programmer saying that they love their life. Touche. Touche. We're gonna look up, what are we looking up? Entity, I think this will be entity doppelganger in boss. Hopefully I named it that. I did not. It isn't doppelganger.c, I believe. We're going to go with that and then go from there. So there's kind of two functions that that run. There's the entry point, which is what DRA calls to update any entity. So DRA is the game engine. It doesn't really know much about what things are currently on screen. Each of the overlays decide what to build, and those in turn have their own logic and own functions. Let me find Oh, where did I do this? Stage, entity, start. Yeah, here we go. So what I want to find here is, it looks like to me that this 801 C5354 function is very similar to the B78 function in Doppelganger. I'm going to switch these. I like, in general, using decimals when I can, but we're going to find this function and see if we can give it a name and see if we can tell what it does. It looks like a void. And then we'll go over to the B06 version of that. Are you saying that Guess 73? So Guess 73 said you can redefine almost any operator and function. Yeah, in Python, right? So I was looking at the data class as well. So there's this data class concept, and it has slots, which I believe translate, instead of doing hash lookups for every member and every function, basically puts them into an array, like a sane object-oriented programming language would, and does index lookups then on those instead of having to go to a hash table. But it seemed cumbersome to use, and there's some subclassing and other things like that in there as well. And it looked like I might have to do some refactoring. The other thing that I was trying to look at is data class has a frozen attribute as well. And if you know, I'm a huge fan of immutable objects. And if you know that you're immutable, you can pre-compute a ton of stuff. And that's how I actually got all the performance out of the type functions in the init method constructor for most languages. I basically pre-compute all that. And so then it's just a field lookup when you're querying for those things, and that drops it down to basically nothing. What you want to do, though, in that scenario is make sure that your object is immutable. And so I did set the frozen attribute on the data class, but it's not quite... I didn't trust that it was actually working for some reasons. So, all right, so we have this function here. Looks like it's an equivalent function to a DRA function. Yeah, and I'm fine actually with operator. Guess 73 saying you can redefine like plus equals. I'm fine with all that. That's okay with me. There are some times where it's just much cleaner to be able to use an operator symbol instead of a function call. Yeah, okay, so if you're adding ends, okay. Fair. I do like a certain amount of dynamism, and that's Swift actually, I think, gets a lot of things right in that regard. Objective-C a bit before it, Swift kind of optimizes some of the things Objective-C did. Basically, you get all the dynamism, but for performance, again, they pre-compute as much as possible. And so when you're calling a function, as long as the class hasn't changed, the lookup time for that is not quite as good as C++, where it might be compiled, or might be embedded at compile time, but pretty good. Yeah, agreed about runtime overhead. That can be optimized, and I think that's what they were going for with slots. I know there's a JIT for Python too. I tried running things through PyPy. PyPy is a Python implementation in Python, which somehow is faster than Python. I don't understand how that could be, because Python's slow. I should say it's faster than CPython. It doesn't seem to support all of the current language features, though, and like format strings and things like that were breaking for me, and I don't know enough Python to know how to fix things like that. All right, we're getting way off track with my hate for Python. Loathing for Python. We're gonna look for this function. It looks like this is the same function in DRA or very similar as the Doppelganger version. So I'm expecting the Richter version to be similar as well. And since we have all these different versions of it, it would be really nice to be able to at least give it a name, if not share it among all the different overlays that use it. I could, I don't, my dislike of Python is pretty irrational. It's mostly like, goes back to about 20 years ago. I looked at Python and I looked at Ruby. Ruby was purely object-oriented, message passing, like pure message passing. That's the only way you could communicate with objects. The syntax was great. It worked. I felt like I said this to somebody at the time, like you feel like a superhero when you're programming in Ruby, when you get it. And then I looked at Python, and Python's like, if you want to accumulate something, you do a for loop. And it looked like, okay, so this is a somewhat dynamic version of C. Did they have proper classes at the time? I remember there was a time in Python where they didn't even have proper classes, right? Anyway, I think that might have been in the Python 2 era. Maybe I'm misthinking that. I might be thinking of Perl. Perl I like because it knows that it's ugly, and it knows that it wants to do things in its own opinionated way. But I think that's it. Like Python, either it was so blah and bland, or it did have opinions about things, and I thought those opinions were wrong or dumb. Okay, so looking at this version of the function, we'll look at the DRA version as well. It looks like, to me, these are all going to be fields in G entities. It's a bummer that we don't have those, but I think we can steal a lot of this from BO4. It looks like it's pretty much the same as the BO4 implementation. Let's look at this DFFO in DRA, though, as well. And see what that looks like. And so all we're doing is offsetting this by, it's a little different, but we're offsetting it by 64, which gets us into the stage entities. The other thing that I have in BO4, and I need to check this against my cleanup, this looks like it should be part of the GDOP global going into the timers. Same feeling with Rust as Ruby. I hate to say it with current people in the chat, but I kind of honestly feel the same way about Rust. I don't know. The things that Rust is interested in are not things that I'm interested in, and maybe I'll just leave it at it. There's certain like OO ideas, like OO in Java, in C++, not optimal. Ruby, Objective-C, they got OO right. Late binding, message passing. Rust doesn't have any, like, as far as I can tell, any concept of inheritance. The interface thing, like, you get away with a lot from that, but sometimes I do want to extend structs, and I don't want to have to embed them in other things. What are we doing? We're going to look at BO4 cleanup. And I want to look at here. I want to see if I got rid of this. And if yeah, I did. Look at that. So in BO4 cleanup, I found that this was timers. And we could get rid of that global. So we have a better version of that available to us. But it looks like that's all this is. The other thing I don't understand, there's so much, I guess I just don't understand about Rust. And, oh, I did all that wrong. I feel like I'm fighting the compiler, and maybe that's once I get past that, I would like it. I feel like I have to do so much in service to the compiler. We can get rid of basically all of the globals. We're missing one thing. We need these entity IDs. The entity IDs we'll get eventually. We'll figure out what those are. For now, we'll just define them all. We use these macros because on the PSP, entity IDs are actually globals and not constants. Sorry, wrong window. So this is going to be grick.timers, and we might have alu-t15. Yeah, it looks like we do. Reset anims is going to be arg1. And, or sorry, arg0. Arg1 is not used. Oh, it is used, but it's, never mind. So arg1 is some kind of timer. I don't know. But I think we have this. Not quite. So we don't have the branches here. We're just setting it regardless. So we still have a branch if equal to 0. Oh, we're missing a branch if equal to 0. All right. A little different. So we can't share that version with Richter. Everything else looks fine. So pretty easy. I'm going to move the entity IDs over into dop.h. Not dop.h. bo4.h. And we need to find this 1b78. Make sure it builds. It does not. And so is there anything we could be missing here? Did we get a... We didn't get any warnings. We could be off... Okay, it looks like we might be off on the entity ID. So diffboss, if you've not watched the stream before, is basically a binary diff. It doesn't do anything terribly special. It just knows how to find where the overlays are in the different versions of the game. And then it does a hex dump to the canonical form and then diffs that hex dump. So what this tells us, though, is where the differences are. So we can get the address of the differences. And we can kind of peek to see what instruction is the difference at. And it's this 71 So 5271 versus 6411. And my guess is that we're just off. On the entity. And we're short. So 6411. PlayStation's a little endian system, so we have to read this backwards. And we load 16 bits at a time for a 32-bit address. So our first part of the address is 8007, then 64, then 11. If we go back here, what is that? That's this address here. I read that as, well, I assume that it was the same offset. Oh, this is where I'm wrong. These should be hex values. So that's easy enough. Oh, it's still wrong. Let's do it again. I might be wrong on this. So we still have different error, smaller error. So Guest 73 saying he landed a 2,000 line refactor and 0 regressions. Was it a refactor from another language to Rust or just refactor within Rust? So our difference is here. This 6363 versus 6334. So we're hex 29 bytes off. Rust to Rust. My general experience with so we're looking at this 63F8. Need to find, so this is line 12. So we're not grabbing. Let's do the math. Make sure that I'm not. So here, we're not grabbing this 63F8 offset. We're grabbing, in the current implementation, it's grabbing 6334. Same thing with the SPIM performance stuff that I was working on. I find that if you have a good test bed and test framework and a lot of coverage that's covering expected behavior as opposed to implementation details, doing refactoring like that can be pretty successful in most languages. Usually, and unless I'm getting paid for it. Usually that doesn't exist. I try to be good about it, but obviously life happens. So let's see. 6363? No, 63F8. 63F8 minus 34F8. That's 2F00 away, divided by 2, or divided by BC is 40. So this should be hex 40, I think. This is a little different. So what I think is happening is we're taking, in the BO4 version, we're taking, oh, not quite. Are we closer? We're still, now we're at 63F3C versus 63F8. So F8 minus 3C, let's see what that is. It's hex 95 different. Why don't you just tell me? the offset that you want. All right, so what I'm going to do is just do the math. We have this offset, and I hate to do it. I hate doing the math. So in our global set of symbols, we're going to grab the G entity's base address and subtract those. Other way. That gets us 3020. And divide that by BC, which is the size of an entity. That gets us 41. But the remainder is cut off. So 41 times BC is 2F BC, and 3020 minus 2F BC is 64, hex 64. And where is, so we're going to look at game.h, and we want to find what's at offset 64. From index. So I was off by 1. Let's try again. There we go. All right, so I want to put these in the B06 header, and we'll make those part of the enum. Does it make sense to use the stage start header? I don't know. So we already have some special macros for specific locations. Do the entity ID numbers change with each overlay, says Cristiano? Typically these first almost 20 or so are the same usually, but then everything else after that is different. And so for Doppelganger 10 and 40, they're actually basically the same, and they're shared between the two, but every stage has a different set of enemies and a different set of item, like interactable items. And so each of those gets, basically this is an index into the update table. And so, yes. So should we use stage entity start? Yeah, I mean, that's reasonable. Is that the right? I can never remember the order of things like that. Where is the other one we worked on? All right. And actually, so we know already that this first one is going to be Richter. So we can just set this to stage entity start and then get the other increments for free. This is kind of a funny enum. This is set to hex 13. It is not hex 13, which is 19. It is very much 16. So far nothing is broken. We'll see. I wonder how much that's copy pasta from elsewhere. I wonder how much that exists elsewhere. All right, so we have this kind of minor, but similar. I'm gonna make a comment actually here to make sure that we remember this. So this is very similar to this doppelganger function. And so one day, maybe we'll come back and somebody will figure out a way to intelligently share these. They're different enough, though, that I think I would keep them unique, especially since the indexes are so different. The indexes between doppelganger and Richter. So we need to, if we're fighting Richter, we're not Richter. So the Richter overlay isn't necessarily loaded. So we need to be able to load it in from this overlay. The BO4 version should be the same though. All right, so done with that. Now that I've offended everybody again. Always offending. The other thing I looked at, oh, it's the same one. I don't want this. The other thing I looked at for performance reasons was, so that was this B78 function. Can we use Ccache? And I was really excited because I've used Ccache in the past. Even though segments might change and other things like that, a lot of times the C that's being compiled is not different from run to run. So even if we cached like the preprocessor output or anything like that, but it seems like, from what I can tell, we're using both CPP, we're using a modern CPP, and then an old GCC for PlayStation. The way that they're being used, Ccache just gives up and doesn't actually cache anything, which is a bummer. I don't think... So in the past, Ccache wouldn't cache standard out, and we do that. We pipe the output assembly that gets created by the compiler to the Sony assembler for the PlayStation, which is a patch of GNU AS. So totally legal, we can do that. And Ccache supports that, but we also take the source in from standard input, and I think that's what Ccache doesn't support. And the reason we do that is because we translate strings. We have ASCII or UTF-8 strings for the text in the game, but they're encoded not that way when they get compiled. So we have a translation layer that converts those to the appropriate ordinals for each of the characters. All right, so let's keep going. Where is... this in here? No. Looking for the next doppelganger. Yeah, it wasn't doppelganger. See, I searched for the wrong thing. All right, so we have the hitbox state, potentially the think state, and we have this. We don't know what this function on 39 is yet. It doesn't have a clear analog. So let's go down to these next ones, and it looks like we might be able to get those as well, or something similar. Is doppelganger thinking in here? It is. Doppelganger thinking is actually a pretty nice function. That's pretty long. No, this isn't the one I was thinking of. Not doppelganger thinking. Let's look at entity doppelganger. One of these functions is the one that should make it relatively easy to control doppelganger. Not this one either. These are both really long, but we can get started on one of them and see. We should actually look for the think step text. Let's do that. So that's this A2C function, which is the top one. And we should see the same thing here. Think step, yep. So I'm gonna give that a name. We'll call that Richter thinking to match. And I need that address. Do I have that open somewhere? And I need A2C. All right, so we'll go grab that and start it. So this is going to be a huge state machine. Gigantic switch statement. Maybe a few other things. Probably one of the larger functions in Richter. But when we get it done, that's one of the bigger ones done. Hopefully it's not too complicated. We'll see. And tab new is not a command. So here's our jump table. Jump table is relatively large. Not sure why some of these get US prefixes and others don't. But we're looking at like 50 cases in this jump table, so a lot of states. Then we have another one. It's only about 8 or 9. And then here's our thinking function. It's big. It's big. Nothing to it but to do it. So let's get going. I like marking these as overridden when I remember, and then I like throwing the confetti when I can. The little things in life. So we're gonna have a lot of go-tos, which is fine. We'll deal with those. Possibly irregular switches, yeah. So we've switches and switches. Switches get stitches. A ton of globals that probably aren't really global. So all of these are part of entities, and we'll have to figure out which they are. Maybe add some symbols to help with that in the future. We do have at least one of these signatures. I think A14 we have as well. But usually those don't matter. So Rick step is the only one that M2C couldn't figure out. And we know that that is just a unsigned 16 field. For some reason, M2C wanted to read it as an array. I don't know why. Let's just fix all of those. Seems like a lot. So I'm just trying to clean up any of these remaining. So anything with a question mark has to get some type before we can use it. The types on the PlayStation version we may not be able to get absolutely correct, but we could still get a matching decomp. We'll probably eventually end up going to the PSP version for this as well. And there we should be able to get the right types for everything. So a couple things. 123, we have a duplicate case. Sometimes M2C will interleave cases, especially when there's go-tos. So we'll have to fix that. Another one between 315 and 113. 488, we're going to deal with this error first, which is an unknown field, which is just M2C not understanding what it is. Yeah, so we're looking at the step, but then we're looking at 2A less than the step. And so it was trying to treat it as a reference and then go 2A backwards. So we'll have to look at the entity structure. Luckily, and I think this is brilliant that Xiaomo and Sozudi and everybody who came before me set this up this way. But they put all the offsets for all the structs, which is really nice. So step is at 2C minus 2A is going to give us offset 2. Offset 2 is position XI high. So the top 16 bits of position X. That's easy to do. And it's odd because we have that right here. So I'm not sure. Usually something like that is cached. So I'm not sure what's going on. The 91 and 123 and this 113 and 315, depending on how tangled this is, these may or may not be hard. If it is hard, I just comment it out and then deal with it later. So let's find 123 first and see what we're doing. So we have case 1 of switch 1. And then up here on 91, we have case 1 of switch 2. We haven't started switch 2 yet. So we have no way of actually getting into the case to be way back here. It looks like this should have been, it's probably a go-to that gets generated by the optimizer. So let's find switch 2, and then we'll fix that case in switch 2. And we're not going to do the go-to. Some of this will appear out of order because we're calling the same function. GCC likes to put the value in A0 and then jump to a line that basically is a jump and link to this function. That's probably what we'll see happening. But we can go up to 91 then and get rid of that switch 2 case. So we can get rid of the case, but we can't get rid of the code because we fall through here. And then hopefully this next one is just as easy. I doubt it, but we have case 7. So we're gonna get rid of the case 7 here. Go back down to switch 2 and add a case 7. Get rid of the label because we can't have duplicate labels. And we're compiling. 78% isn't bad. So there's going to be a bunch of stuff to do. So we have some randomness here. The first thing to make this easier to follow and comprehend, let's go grab all these offsets. These offsets probably are going to be fields in the Richter struct, and we just need to figure out what they are. I'm going to do this. I'm going to put the offsets here. And we're going to look at the base symbols.us. I'm actually going to move all these because if I edit them here, this symbol table is relied on by everything. And we don't typically put symbols outside of the overlay in the overlays config, but in this case, I know that these will only be used by Richter in this form. I shared them here in US originally because Doppelganger, all the symbols were the same between Doppelganger 10 and 40, so I had 2 overlays that needed the same symbol tables. In this case, though, I don't. So Richter is going to start at DE 807's 62DE. D8, sorry, D8. And we can verify that by going back to, oh, I closed it, didn't I? Yeah, I closed it. Yeah, this is Boss Richter, that's right. And I don't think you were around when we started this last week, Mozilla, but this looks to be the same as Doppelganger in that it uses a virtual control pad. And I don't think so. Last time I was so excited that I found all that, and then you're like, Soten.dev has all that. I don't think Soten.dev has this, does it? Oh, it does! Control Richter boss fight! It does. Well, we'll find that eventually. We'll rediscover it. Anything that I find, Soten.dev will already have. So this is our base address, 76D28. We're going to go through and get past all this stuff. I can't wait till the day, though, that we get to profile, do some performance benchmarks and profiling on Soten. That'll be fun, right? It sounds like a grand. I mean, fortunately or unfortunately, that is what I like to do. at the... Oh, no. What did I do? This is... No, this is after. No, it's before. Oh, drat. It's an entity before. Shoot. That was not expected. It's actually before the entities table altogether. Drat. Where is it? Is it possible that this is part of... Do we not have any symbols for these yet? So this is 807 to F12. So it's part of G player. And this will be actually already in here. So these are player symbols. How can I say this in a way that I don't have to tell YouTube? A nice glass of a fermented beverage that's made in a particular area of the United States, say Kentucky, and look at graphs of timing data and tweak some code and then regenerate those graphs. Oh, that sounds like a lot of fun. 80072. Can't type. Okay, so we're looking at G-player timers for all of these. Timers are each 16 bits, so we just divide by 2 for each of these. And this 12 is not going to be a decimal 12, so we got to remember that 12 is actually 9, believe it or not, in decimal. And we have enums for all of these too, I thought. This one we just have 9, so we have let's see, 9, 10, 12, which is Dark Metamorphosis. But these are Richter. Oh no, these are the player timers, because we're looking up there. So what did I say? 9. Nope, we're skipping Dark Metamorphosis. Just looking at 12. And then skipping Invincible and looking at Invincible consumables. Shouldn't, yeah, when I generate Richter with a size, shouldn't it generate Rick? Yes. No, it doesn't generate the symbols. When it generates the assembly, it should do grick plus the offset. I'm not getting that, and I don't know why. And I'll have to look into that a little more. We have one more of these to find. It's outside of timers. So something after graphics load, something that does not have a symbol yet. Let's look for that address in either... It must be in main's map. I think that DRA starts at 800 or 010000, all the zeros after that. We'll see for sure. It's possible that there isn't anything defined at this yet, which is would be wild if we have a new symbol in main. There must be something that references it somewhere. We're just gonna look at all the maps. So we do have a symbol. It looks like it's automatic. Nothing has nothing has defined it, nothing has used it yet. So let's look at ASMUS. We do have references to it. So Entity Enemy Blood references it in a different way. So let's look at Enemy Blood and see what's going on there. Hey, Fred. So what are we looking at here? Let's find out about where this is. Oh, yeah, thank you, Dizik. That is correct. I hadn't thought about that. Yes, defining symbols that overlap with a sized symbol, that does screw spam up. It doesn't know how to deal with that. That's exactly what's happening. Okay, so I want to fix this too. When we're building, or when matching symbols get exported, we don't regenerate symbols, a symbol table from what we've compiled. And so matching functions don't get symbols that came from C. And that makes dealing with this not ideal. So we have initialized entity. So we have to do some work to figure out what this might be. Looks like it's this GAPI function. So we're right after this GAPI function. What I'm trying to find is what the equivalent of this 72F2C is. I think it's prim buff. We need so we're looking for a global in here that oh, it may be more than that. So we do have a -1 right around there. This is the -1. That's much too early, though. Either call it random. Ugh. All right, let's. This is another way. I don't want to have to spend a ton of time doing that. What is the symbol that we do have that is closest to? Where's my? So I want the symbol just before this, which is graphics load. And are we using graphics load here? No, we're not. Why would we? Let's look at that. Map file. Oops. I want to look at the map file again. Oh, so it is part of... It is part of G player. Oh, it's a timer. Yes? No? Why did I think it was not part of G player? Okay, now I have way too much open. Can't find anything. Let's try G player. Oh, it could be one of these G player unknowns. G player, though, should have... where's game.h? There we go. 807. F2C. Status. What is wrong with my gripping? Sorry about that. That took way too long. All right, so we'll do each one of these. We want to get rid of as many globals as possible. Give me 1 second, Fred. Why does it show 100% done? Why, Fred? Because those are 100% done. They actually are. For real. DRA is... I'll have to go back and check, but I believe DRA is done, as in... it is completely... All the data is done. Richter and Maria. Richter from PS1 and Maria from PSP. I know those are done and they're portable, and you can compile them for on a modern C compiler even. Yeah, the graphs are totally broken. I've not looked into it. I just add the graphs. I didn't write them, and I haven't looked at them. I don't understand how they work. Like I tab different places and they do different things. The other thing that they do, which is not ideal, is it says that they were done today. No, they weren't done today. They were done at some point in the past. What point in the past? I'm assuming that what is the data source? Something frog. Like decomp frog, not decomp frog. What is it called? Progress. I'm guessing the data in progress is correct, and just the way that it's being translated in that in the web app is wrong. All right. It looks like I'm missing some of these timers. They were renamed. Why? I don't know. And so we're kind of back where we were. Next thing is finding each of these. I'm hoping that these are part of GRIC. I'm pretty sure they will be, but we have to go find them. Find my list of offsets here. GRIC, I don't have anything overlapping that at the moment. So these are 1D. So these first ones definitely are not 1D 2C8. 1D. So these will be GRIC. And I think I'll add symbols for those. These other ones are not, they're earlier. 1D, 11C. So it doesn't look like we have those yet. So I'm not going to go through the GRIC stuff right now because that's a little boring. Maybe I will, I don't know, we'll see. I will fix these entity references though. This can change, so going from a global symbol to a struct access, it can change what GCC does. GCC might decide to cache like the base address and then just do math. Other times it doesn't. It really depends, and you don't necessarily know what GCC is going to do. At least I don't. I can't guess. Same thing with these addresses though too. When they get changed to struct access instead of direct addresses, that can change behavior as well. And I missed velocity Y somewhere. But that didn't do anything. Made it slightly worse, if anything. And the reason it makes it slightly worse is because it changes a symbol that showed up originally in the assembly with a base address, which is the RIC entity table plus an offset, and that doesn't match. All right, so the next step is simple things, and then undoing a bunch of the go-tos. Go-tos typically will be just duplicated code, usually. Sometimes it's control structures that M2C couldn't figure out. There's assembly for functions that are not translated to C, checked into repo, or generated locally from ROM. They're generated locally from the ROM. Technically, the assembly, even though we're generating that assembly, it's a mechanical translation from the binary, and that's not protected by fair use in US copyright law. So I can use this for my own purposes because it's my game, but we can't check it in and share it with other people. And then the code we write ourselves, and I have lots of documented proof that I'm doing this myself and not getting this through an automated tool. And so that's our creative expression that just so happens to match and compile back to the same thing that the original game had, and so we can check that in. So I'm going to look for, basically for each of these go-tos, I'm going to find other places that they exist. By the way, the question was from Guest73, is assembly for the functions that are not translated to C checked into the repo or generated locally. So that does, so one of the things that, if you haven't seen it yet, Zyynamo was able to recompile the PSP Maria for PlayStation and get a version of the game out that had that in it. If you have the game, you can check out the repository and it'll do all the things for you to build a new version a new ISO that you can have that will play that version of the game. We can't distribute that game in any way. We can distribute the source to build that game, but you have to have your disk to build that. And we won't ever ship things that we don't create ourselves. So for each of these go-tos, typically what GCC is going to do, and when we get to, when we look at the PSP version of this, we'll see this. We'll find that these aren't actually go-tos. They're just duplicated code. And GCC decided to optimize it into a smaller function by using go-tos instead. And I need to be careful. Whenever you have a go-to, you need to consider what the flow of the rest of that function looks like. These are easy because they return right away, but you have to grab that too, just in case something else happens. And there are things like this where either path is going to return, and so I might rewrite that. I usually don't do this while I'm in the middle of it, but I'd probably rewrite it like that, and that's probably equivalent. But I just go through each of these, get rid of the cases, and just keep doing that over and over. There's other things like this. It's a global getting set, and we set another one and return. Let's actually do the 201 and 202s first, and then we can get rid of those, and that'll make it easier to get rid of the 200. And some of the return statements and other things like that I'll deal with later on. And at this point, when I'm cleaning up, I'm not really looking at the percentage, how close we are. So this percentage says, this C code, how close is it to the code that shipped on the disk? Is it close or not? So it says it's about 80% similar. It's nice if that number at this point gets closer. For a big function like this, it probably will be getting closer as I make these changes. But I, just from doing this so much, I know that structurally that this is likely what it is. And so if it gets further, it may get further away as I'm going through until I get the last go-to replaced, and then it will jump back up to being almost identical, or a much better number. And so I don't watch it while I'm doing this because I know that it will change in ways that don't really affect me. All right, so 201 and 202 are now gone. And that just leaves 200 up here. But I don't have to worry about copying those other labels. And you might be looking at this and saying, is all this code really duplicated all over the place? And the answer is typically yes. In this case, we see that basically the reason that label was there was to pull this var v04 out, and we're going to be able to get rid of that as well. There's going to be slight variations in all of these. And we can get rid of most of those. V0 is a register used for ephemeral values. It's usually, not always, especially in GCC, it's not actually something assigned to a variable. And that lets us get rid of a local. So here we have another one. Again, careful of the control structure. What happens if we would jump down to this block 16? We're going to call the function, that's fair, and we're going to exit this, exit this, and the next thing that we're going to do is font print. If we just copied the function there, we would fall down and execute this code and potentially execute that function, or call that function again. That's not what is going to happen there. So we're going to change this to an else, and that'll give us the correct behavior. And even more than that, we might be able to make this an else if, and get rid of one of these. It may or may not work that way. I don't think the number changed, but if you were paying attention to the number at all, it was around 79% before dealing with all those go-tos. Now it's at 84%. At some point, when you hit enough of them, the optimizer starts behaving the same way as it did when the game was originally compiled, and starts sharing all that code again. And we just keep going through, looking for all the go-tos, and trying to... This is probably going to be something similar. I'm going to turn this into an else because it doesn't hurt anything. But my guess is that we're going to call some function, maybe with a different argument, and then return. Hey, what do you know? Don't need the return. So this function is big, but it doesn't look too complicated so far. For switches like this, I'm going to do this quickly. We're going to move the arg there. Basically, we're randomizing how this behaves, and the default may be cases 2, 3, 4, or it may be default. We can't really tell, but at the end we return. We can replace all these with breaks, which is slightly nicer, at least to my eyes. And keep going. That dropped us a little bit. That's okay. We'll go to block 210. Let's do block 172. That one's easy. This one may, depending on where this break goes, that may already be a return. We can fix that later. Let's look at it. So one of the bigger functions that I've worked on recently. So if we fail, we're going to go to EF4. If I remove this return, where are we going? Still going to EF4. So that's perfect. And probably the same thing here. But I'll take a pass later to clean all those up. So we have some interesting logic here, and sometimes GCC does crazy things. So this is probably facing left, and position X is greater than 80, or that whole thing, or position X is less than 80. And then we hit the same condition either way. It may compile to the same thing. On PSP, it wouldn't compile to the same thing, I think. And so, again, we'll look at that when we get there. This is kind of a, just a slog to kind of get through, but it will pay off in a bit. This is probably going to get worse until it gets better. Go-tos with go-tos, you gotta love that. I should have actually done block 186 first, that was dumb. You can't win them all. Or maybe any of them. Can you win any of them? Same thing here. I'm including the return, even though it might not be necessary. I don't want to concern myself with those details yet. In this case, I'm going to. That can be cleaned up later on. And I'm expecting this to get relatively close with just cleaning up the go-tos. I don't think that there's anything like super complicated, no geometry and graphics functions or anything like that. Okay, that one's done. Oh, how many of these are there? Okay, so this one's tricky as well. If we set this, we're going to fall down to here. We're going to fall down to here. And we're going to fall down to the break. So we always need to make sure that it's returning. And I think I'm just going to explicitly put the return in. Oops. And then GCC should do the right thing. We'll find out though. YouTube's making it. He verified that it's me. It's me. It's me. It's a me. The VAR-v2 thing here. Oh, this is it. There's some more cleanup that needs to be done here. When we see this v0 being assigned one thing or another, depending on a statement like that, probably what's happening is actually this. And these may be inverted. As the 8000 came first, it may actually look like this. Temp S0 probably is a variable. It looks like that probably is facing left, if I'm reading all this right, yeah. So this is basically some logic here to determine what direction Richter's facing, or what should be facing. We'll keep working on the go-tos. Only one of those. Same thing here. We'll see the same kind of pattern over and over and over. Call this function one way or call it another way. And there probably is a doppelganger analog that we can look at. It might be getting close. Again, being careful to grab the break at the end of this, the implicit break. And that's it. We got all the go-tos. A little lower than I was expecting. I was hoping closer to 90 or so. There are definitely some things in here, though, that are that seem wrong-ish. And so we'll start cleaning up other things. I'm still not going to focus on like minute differences between the assembly at the moment, because there's a lot of other cleanup that can be done. A ton of returns here that are superfluous or could be replaced with other control structures that may or may not help. We'll see here. Something like this, var v0 being set to 1,000 and then being set to 1,000 and then being assigned. There's going to be a ton of stuff like that. And sometimes when it's explicitly in the code, the optimizer doesn't optimize it the same way it would have had it been written like you'd expect. Any returns followed by other code that eventually returns, usually those are an else. Not always, but often returns in the middle of that are just going to return anyway. So all of these steps probably, I'm going to save this where it is. Let's go look at Doppelganger. I'm hoping that, so Doppelganger is largely the same as Alucard, and has a lot of the same state machine as Alucard. And so I'm hoping that we can look at the steps of Doppelganger. Which are somewhere in here. Not many. Richter definitely has a lot more than this. But then look at this implementation. Okay, so we have think step. That's what I was missing. So we have our think step here. These are unfortunately they're going to be different, and I didn't grab or go through and determine what each of these are. But we see in the Doppelganger code we have a simulated pad. We're setting that pad to buttons, and what do those buttons do? Exactly what the buttons on the control pad would do. And then there's code that looks a lot like Alucard's code for Doppelganger that interprets that pad the same way and does the same thing. And we're going to see the same thing for Richter. Basically, we have duplicated code that look at a different player state, a different control pad than the input control pad. We do have a lot more steps, though, so a little surprising how many steps there are. Much more complicated boss than Doppelganger. All right, what am I thinking about? I think going through and looking at the var v0s, trying to get rid of most of those if possible would be good. Var v0 itself, interestingly, is a variable. So this is the difference between Richter and the player, the absolute value of that. So we're going to call that we'll just call it delta x. Delta, no. Call it distance x. Player distance x. I will replace the let's get back to that. So this is not an if statement, it's just going to be the absolute value built in. And usually we don't have odd numbers like this. So my guess is that this is a less than equals. Less than equals is kind of as uncommon as an odd number. Likewise, this probably isn't greater than equals, it's probably greater than 58, x58. Temp s0 I'm going to call facing left, and that is going to be a variable. As I name these, I like to pull them up to the top. The ones that don't get named are likely not actually variables. We'll find the other var v0s. And try to get rid of as many of those as we can. Sometimes it's this is actually a pretty gross function or condition. So we have an assignment in the middle of this. The assignment is part of GCC's optimization. So this var v0 underscore 5 is not used unless this condition is this whole thing is false. And so basically on both sides of the branch, GCC is generating the same code. We don't need this second one because temp s2 does not change. And what is temp s2? So this is like the global X, like Richter's global position. So we'll call it that. Interestingly, we have another temp v1. I think that this is that's ephemeral as well. So this facing left is like whether or not this is negative. So this is a fancy negative check. We'll get back to that in a second, though. So this var v0 underscore 5, we don't need this assignment here. It's just duplicate. This is not needed. Facing left is almost always a Boolean and treated as such. this looks like this 15EC. Looks like a, oh, this is going to be G-pad. So we probably can mark this, and it would be good to create a symbol for it as well. Let me do that quickly. Keep the comment about which switch is which. So yeah, let's look at this 15EC. That'll make reading this a little easier. Just wanting to make sure that that is what it is. So we're going to take this 5EC starting address, subtract the GRIC base, that gives us 324. Then go to game.h, add 324 to the G player base offset. We get 72E4, or EF4, sorry. 72EF4, and that is pad sim. So I'm going to add that symbol because that will be nice to have. We can't put struct fields directly in to the symbol table. That syntax is not supported in assembly. So we put the name of the global and then an underscore. And what that's going to do is break this other GRIC symbol that I have, because now it can't extend that whole distance. It's better this way. This is a better symbol. So I'm going to keep it the way that it is. And as I find these, I will slowly add them. And that might get us, oh, that was actually, let's see what that did. 88 to almost 91. Just changing a little symbol name. And now I need to find where I was. I lost my place. I was looking at the var v0s, that's right. So really so far in this function, there's not a lot that's difficult. The major issue is just the time that it takes to do it. Pad sim is kind of a pain. We don't have a linter for it. The reason we don't have a linter for it is because those values are different between the PSP and the PlayStation. And so our linter would have to be aware of what version of the code that it's currently looking at. And currently it does not support that. It would have to have basically logic to understand how to interpret the macros. And I don't know if it makes sense to really do that. There's not usually a lot of pad sim code anymore, except for bosses like this. And the only reason this particular boss has code like that is because it's for using a lot of code from Richter. I don't think other bosses really do this the same way. All right, so we have one var v0 left. I think that it's basically the inverse of this expression. I think we can get rid of that one too. Yeah, that looked good too. So all of our v0 is gone. And most of the time, getting rid of as many variables as possible is also a good way to succeed. So here we have I'm going to go with not minus minus. This looks like a timer. That's how timers are usually implemented. I don't think that changed. Some of these I will 93.24 to 93.04. It's not happy with that. Let's pull this out and do it first. Let me look at that again. It's not equal 0, so I did the wrong thing. No negation. And now it's the same. Whether or not this is happening inline, again, you'd have to look at the PSP to determine that. And the same thing here. This one is a knot. No change in the match. Just getting closer to correctness. RA0 is usually an argument, and in this case that is exactly what it is. And this is used when we probably got rid of a go-to somewhere in there. This is an and. This is probably truthy. I'm gonna cheat because I don't want to think about this again and look at the BO4 implementation of this. I don't recall offhand. The facing left calculation. Oh, that's simpler than I thought. Sometimes they do an XOR, but not in this case. I'm guessing that this is kind of a guess that it's the same. It's possible that because a lot of this code looks the same as Doppelganger, it is possible that this was written by the same person as Doppelganger, and if it's written by the same person as Doppelganger, then you can kind of rely on or expect a lot of the code to be very similar. And that did actually improve that a bit. So all those are gone. Just a RS1 left. And we're at 94%. Okay, so this is interesting. VARS1 is not set, but it is red. That is definitely a possibility, but more than likely is a bug, either a bug in my refactoring, which is often the case, or something else. And so what I'm going to do is, let me find this facing left. What we want to do is find where the S1 register is being used. Because here we're using S0 correctly and not S1. I might go back to the decomp and see what this looked like originally. We won't have a lot of these. We won't have a lot of these other things in place. So this is switch 1. Let's see if we have this case. So this was part of case 1. This is this check VARS1. Let's see where VARS1 was set here. Oh, VARS1 is VARS1 is player distance X. Nope. What do we call this up here? Global pos X. Yeah, I missed that. Okay, so RS1. And curiously, that did not affect the compilation at all. Sometimes that happens, and I don't understand exactly why, but like coincidentally, did this get saved to the S0 register? But then S0, the variable, should still be uninitialized, so yeah, I don't know why that worked. We went down a little bit. That's okay. Some of these are likely out of order, and so I'm going to go back to this original version again. So here we have the demo timer. Probably grab that as an address as well. And so, but taking this order that I've seen before, and we translate it to this, move this up, and does that give us the correct? No, it doesn't. I was hoping that would give us the correct compilation here, but it doesn't. That's okay. We can replace all these with grick demo timer. Demo timer is the name. It's called PL demo timer when the debug prints are printing that out. Actually, this might do it. Oh, no, I was hoping it was. So when those are getting printed to the screen, sorry, thinking about something else. When they're getting printed to the screen, it's called PL demo timer. It was called that as a field for a long time. But the PL was redundant with, normally this is G_player. Now we have cases where it's not the player, but demo timer remains. And it's how long the character is going to be still. And so here we have, these are going to be the think steps, this 3C8. We can put a comment here. This is the think step. And we should see that as an argument to the font print for think step, and we do. Okay, so what I'm trying to find is do we have any of these others that are known? I don't think yet. So we do have all these though. These are all going to be fields in Richter, and so we should probably figure those out. And mostly it's just doing the math and adding the symbols. A player state starts with a big set of colliders. And so it looks like I did put in offset 318 here. So we have basically X318 bytes of data before pad pressed, which is what we're interested in. Back over here, I have the offset of pad sim, which is 5EC. So I need to, basically I can find the offset of these based on pad sim. I don't know if the Windows calculator does this. I'm sure there are programmers' calculators on Linux, but calculator on Mac OS has a nice hex calculator built in. And some of these I can then just go and continue on. This is going to be plus 12. So it's 38. Remember not to copy the D. Yeah, I suppose Excel would probably support hex, like standard hex notation, hex literal notation. Oh. Correct. This is plus 44. That seems too small. I need to add a plus 2C. So let's figure out those first ones and then see. Patson is. So I got the first three. I really dislike doing this math. F20 is VRAM flag. And as these get added, it's probably a good idea to go back and regenerate the assembly as well and just make sure that everything is lining up as expected. I won't do that today. F2C. Didn't I already have status? Maybe that was on the other one. Should have done it then. Save myself some time. Status seems fine. F 64. All right, so I'll start with those three and then we'll see if that gets us any closer. It should get us hopefully a little closer. Sometimes it gets closer, not because addressing is different, but because the type is corrected. And the type, less so in GCC. GCC is definitely less sensitive to it, but sometimes the type does make a difference. You might get extra masks or other things like that in there. And a little worse. That's okay. Sometimes it gets worse before it gets better. I'll work on the rest of those later. So we're dealing with some issue where these loads are happening in the wrong order. A few instructions here and there that aren't necessarily as expected, but mostly this seems about right. A switch here that may or may not be a switch. It could be something else. We'll have to see. It could also, like I was saying before, it could have all the cases spelled out specifically. They could also be out of order. It looks like there's a missing label in here. We'll have to find that. One of these switches may not be generating the jump table, even though it should be. Actually, let's try that. I'm going to go back here. I think that's what's happening. So we have cases 0 through 7, and that's probably true. And I think I pointed this jump table out when we pulled. But basically, after a certain number of cases, GCC generates a jump table instead of just putting it inline. And so this is close, but not quite right. These may be out of order. So some branches to the wrong place, but other than that, that looks good actually. And so if we knew what each of these roles meant, we might be able to figure that out. My guess is that F4 and F50, or F00 and F50 are about the same place. We have to look at the address over here. Yeah. So that they're both a return. We have a little less on the stack than we need. And there's some instructions missing, but those will work out to be the same. So that's how that switch was supposed to look. I think that's where I'm going to leave it though today, and we'll come back to this function. Pretty straightforward, nothing super complicated here. Mostly just mapping memory addresses. We're learning more about what fields each of these addresses are for, and that'll help later on with other functions. And this is actually a pretty good one to have because it's relatively straightforward and it helps us find memory addresses. So this is Richter thinking, which is the function that determines what Richter is going to do next when you're fighting him as a boss. Will knowing what how he thinks and what he will do next, will that help you beat Richter when you fight him? Probably not. At least it wouldn't help me. But it might help you. And of course, this is Richter from Castlevania Symphony of the Night. Go to soten.z.dev. And you can learn more. You'll find the link to the source code, including the reverse keep, which we did a couple weeks ago. That's in there now. Join us on Discord. I don't spend a lot of time on Discord, unfortunately. I'm really bad at messaging platforms. But come back tomorrow, we'll do some more. That's all I got. Adios.